right, you guys, so piecewise functions, this is going to be one of the constructed response questions on the test tomorrow. So I'm going to show you how to put this in the calculator. Okay, so as you can see, I've already put in the first part of my piecewise function. So remember, it's just that this is the graph we're going to look at when our domain is less than or equal to 1. And this is the graph we're going to look at when our domain is greater than 1, right? So just off the top of my head, before I show you on the calculator, you don't have to know this, but for some of you, this may help. If this is 1, okay, then 2x squared plus 3 is going to be a parabola that is moved up 3. Okay, so it's going to go here at least, something like this, right? And then the bottom function, 3x plus 6, is going to cross, our y-intercept is going to be 6, but we don't care about that because it's not actually going to exist until positive 1. So my best guess is it's going to be, and its slope is 3, somewhere up here, but it's going to be an open circle there because we have a closed circle for the other one is equal to it, and it's going to be something like that. So let's go ahead and put it into our calculator. So there's the first part. I had already put it into the calculator. If we go to y equals, you have to put in the 2x squared plus 3 in parentheses. So where my cursor is blinking right now, that's the first parentheses. And this is, whoops, went too far. And that's the second parentheses, and that's my equation. Then I do another parenthesis, and I type in x again, and then less than or equal to, and you can find that under test. Test is second math button, and it's number 6, that's less than or equal to, okay? And then 1, and then parentheses, okay? So let's type in the second one. The second one is just that linear, but in parentheses, 3x plus 6. You might want to take notes on this so that you have those available for the test tomorrow, right? Parenthesis. For x is greater than 1, so parenthesis, now we're going to do our domain, x, and then second test is greater than, that's at 3, 1, parenthesis, graph. Cool, so I'm going to zoom out just a little, well actually what I want to do is I'm just going to change my window so that my y goes up farther, let's say 50, and let's say my x gets bigger to, let's say 20. Whoops, looks like I have a stat plot in there. Let me clear that out so we have a better idea. Turn that off. Okay, go back to the graph. Cool, there we go. So kind of like I drew there. And this is asking for a table, so we should just be able to go to our table, which is second graph. Okay, so here's the thing. Your table is only going to have y1 in it up until 1, and it's 5, and you can see it's 0 over here. And then it's going to scoot over here, and for 2 and everything after 2, it's going to be in y2, right? And what else is it asking for? Determine if the graph is continuous. Well, we can see it jumps. It makes this jump right here. It has a jumping discontinuity because it stops here, and then you have to pick up if you were following it with a pencil or a highlighter. And then it has to jump up to the top to continue. So it is not continuous. It has a jumping discontinuity in it. Cool. All right, what's next? Sketch the graph and create a table for the piecewise function defined below. So let's practice this. Let's see. We'll go to the y equals and parenthesis negative x plus 5 parenthesis, where x second math is less than negative 2, and that's the first equation and domain on my piecewise function there. I'm going to arrow down, parenthesis, parenthesis, parenthesis. I need 2 there because, as you can see over here, my function has a parenthesis in it also. Then x minus 1 parenthesis squared minus 2 parenthesis, because that's the end of the equation. Then open parenthesis. This one's going to be tricky because not only do I have to know that x is greater than or equal to -2, okay, that's 4, parenthesis, but then I need another parenthesis because I need to know that x is less than 3, that x is less than, whoops, 5, less than, whoops, how many times have I just said whoops? Less than 3, parenthesis, arrow down, and then parenthesis, -x plus 5. Oh, you guys, look. Well, we can write this in twice, but do you see how the first, check this out, this first, whoops, this first equation and this equation, they're exactly the same. I'm going to just go back and see if I can't, in the calculator, go back up and add an additional domain to, so I already have x is less than -2, and then let's just do another parenthesis and say x is greater than or equal to 3, parenthesis. Let's see if this works. I'm just going to do a zoom 6 to see if that'll give me anything. That's my basic standard button. Whoops, it did not like something, so I go directly to it. Oh, x is greater than or equal to -2. How did I miss that? -2, and then parenthesis, x is less than 3. Less than 3, parenthesis. Okay, didn't like that. But it told me that. Always read your error messages and you can figure out what's wrong. Okay. Cool, we've got that. Let's zoom out. There's that middle part. It's not giving me my other equation. So I must have done something wrong with my domain. Let's see. I need to add something in here. Second, insert this. And x greater than or equal to 3. Oops, now I zoomed out again. Let's try this. All right, you guys, so it looked like I couldn't just do the domain like that. So what I did was, look how much you're learning from my mistakes. What I did was I put that one equation in twice. So as you can see, y1 is -x plus 5, where x is less than -2. y2, the middle one, where I have both parts of the domain. So I guess you just can't have them opposite. y3, -x plus 5, same equation that's in y1, except where x is greater than or equal to 3. Then when I just did a zoom 6, I got this. So that's cool. Check that out. And this is continuous, right? This is continuous. The table is going to be here. So the first table, let's go, whoops, let's go back. The first table is going to be y1. I can't stop it. The first table is going to be y1 all the way up to -2, right? Then we start the table goes to y2, and that should be just to 3, right? 2, 3, and then the table goes to y3, because remember I had to put that back in there. So 2, 1, there. All right, so the piecewise review below and determine if the graph is continuous. So we said it is continuous because you did not have to pick up your pencil if you were going to trace that graph there. Sketch the graph of this one here. So I'm just going to do this last one, 126, and I'm going to let you guys do 196, or 126 looks a little bit easier than these, so maybe I'll pick one from 96 because this is a lot of questions we gave you guys, right? Determine if the function is continuous. So my suggestion would be you try all of them to practice with the calculator. And I will do one more. Okay, so graph this. So the first one is, remember, put this in parentheses, x plus 4, parentheses, and that is where x is less than negative 2, x is less than negative 2, arrow down, then we have parentheses. I'm just going to do 0.5 so I don't have to worry about fractions and parentheses. X squared, where x is greater than or equal to negative 2. So 4, negative 2. And we are going to, I think we're still on Zoom 6, so I'm going to graph this. Cool, and it also looks like it's continuous. Oh, that's cool. Look at that shape that that one makes. Okay, so practice the others on your own for these piecewise functions in the calculator. I'm going to, was that the last one there? I'm going to go ahead and stop this one here and move on to unit circle.